What's up guys, Shawnthebro here, and we're back for another episode of the 3D fighter conversion. So we have the fighting game tutorial series, and that is a 2 and 2.5D fighter. Then we have the 3D fighter series, which is using that framework, using our template to make a 3D fighter. So when we come into our game here, we can select our character, select our stage. We get into the match, and normally I see this sort of movement, right, our 2D behavior. Nothing out of the ordinary here. And then I can enable my 3D mode to see this right here, which is where the characters can actually rotate around each other and they can move based on where they're rotated instead of just left and right. And we also use the complex hurt boxes, as we call them. So if we go to practice mode, you'll be able to see that we have these 3D hurt boxes instead of these 2D hurt boxes. So these are our standard hurt boxes for our 2 and 2.5D fighter. When we enable 3D mode, we get these 3D hurt boxes. Now, in today's episode, what I want to do is just go over a few things that we could improve in our 3D fighter because the logic just isn't right. One of these perfect examples is the fact that we don't allow the character to rotate when they are blocking. Now, we did disable some behavior when they were blocking for the simple 2D and 2.5D fighter mode, but in this case, the character actually should be able to block and rotate. So as we move around them, they should be able to rotate around. Right now they're just staying in place because I have my practice mode AI as just standing completely still, blocking the entire time, but we want them to actually rotate to face us. It's a small thing, an easy win. Another thing is we should be able to deal damage to our opponents. We have all the logic in place already to use our complex hurt boxes, but there's something that we're missing. Allow us to deal damage in 3D fighter mode or just our complex hurt boxes in general. That's another easy win. Another thing that can be easily improved is something like our jump. So you notice when I jump over to this side of the character, if I try and jump back, I'm actually going to jump the opposite direction. Even though you can see the input stack is outputting the right symbol, I am jumping the opposite direction. And when I go this way, and jump the opposite direction of what you would expect, I can actually jump the expected direction. And this is because the jump logic is based on if we're facing right or not, because it was based off of the 2 and 2.5D fighter. So we're going to implement a jump that is applied in the direction that we're facing, not left or right. These three different things and a few others are going to be in this episode, and cleaning these things up is going to make this mode, this 3D fighter, a lot more playable. These minor things are actually making it much harder to use the 3D fighter, which makes it much harder to see what we need to still accomplish. Now, don't worry, I know we still need to do the camera, and we still need to deal with this whole the capsule collider is moving as I walk into my character, so I rotate when I walk into them. They're still on the agenda, but I want to take care of these other things first because taking care of these things is going to make it easier to take care of some of the other things. Now, before we hop into this episode, if you want to get caught up in the series and check out how we've done everything from our input stack, our special moves, our input buffer, our practice mode, and a whole lot more, I'll link you to the entire fighting game tutorial series playlist right here in the top right corner. That's everything from our 2, 2.5D fighter and the 3D fighter. Alternatively, if you only care about the 3D fighter and getting this working because you want to create a 3D fighter, don't worry, we can still go ahead and implement that and make that work without watching the rest of the series, although they are coupled pretty closely because they're using the same framework. You can just watch the 3D fighter episodes and get a very good idea of how we do a lot of the 3D logic in our game. So I'll link you to the first episode of the conversion from the 2 and 2.5D fighter to the 3D fighter in our fighting game tutorial series. And with that out of the way, we can go ahead and get started. So this is a code and blueprint tutorial series. We're going to be improving things in both the blueprint and the code today. So we'll be working in both. The first thing that I would like to take care of is the collisions. So for a while now, our 3D hurt boxes and our complex hurt boxes have not had the ability to damage the character when we collide with them, even though we set up our 3D hitboxes. If we go to our blueprints, character BPs, and we want to go to each of our individual character classes that have these complex or these 3D hurt boxes on them. The base character BP would work if you have them, but I don't have any complex hurt boxes on this character. They're on the individual children classes like the mutant BP. So if we go to the mutant BP and we go to the viewport, we can see our simple hurt boxes here, but we also have our other types of hurt boxes, such as our left arm, head collision, middle, which is just body, right arm, right leg, this sort of thing. And they are not visible in here by default. So you'll see visible set to false when rendering, but I can render these at any point, and you'll see things like left arm. I'm going to keep them hidden, however, I'm going to go and select all of them. You could select them all manually, or just left click one and then shift left click to select the whole section. I know all of my complex hurt boxes end with collision HB for collision hurt box. So I've selected all my components. You should select all of yours for each character that you have. Then you should go over to the details panel, and specifically you want to scroll down until you get to your collision section, and you want to make sure generate overlap events is true. We had disabled it at some point in the series because we didn't want to support 2D and 3D at that time. I just had made one episode on these 3D hurt boxes, and I didn't want them being in the way of our character all the time or taking up extra performance. Since that point, we had greatly improved the complex hurt box system. These concerns aren't concerns anymore. And because of that, we need to make sure that we generate our overlap events again, because we are using them in our game now. And if we don't generate overlap events, then we can't overlap our hitboxes with them to deal the damage. So every single one of these should now have generate overlap events turned on, and you can see that they do. We can compile and save our blueprint. Again, do this for all characters. Then when you're done, you can go ahead and test it out, but this should now work. So if we go back into our training room, we have our hurt boxes, and we can attack them and deal damage. Now if we go to 3D mode, you can see our 3D hurt boxes, but now attacking them deals damage just like we expect. So that's a huge win, very minor change, and now our 3D hurt boxes and our complex hurt boxes are working. Next thing on the agenda is that blocking behavior that I talked about. In 2D mode, I see that my character is facing the proper direction, and when I jump to the other side, they rotate, or really they flip their sprite, flip their X scale to be facing the direction of the other mutant. This is what we would expect. When we go to the 3D mode, we don't have that same luxury. We use a rotation to determine which way they should be facing, and no matter where I rotate, they don't move. But again, for my game at least, I would like them to rotate. They can be standing and blocking, but they can still rotate to face the character they're looking at. This makes sense, right? Probably should be looking at the character trying to attack them. So let's go ahead and look at our blocking logic and our rotation logic. So here I am in the code. And the first thing we can check is our rotate toward opponent 3D. And rotate toward opponent 3D is a function that we have specifically for the 3D fighter. It is called in tick. Instead of doing the scale flipping logic that we have for our 2 and 2.5D fighter, if this is a 3D fighter, then we just call this every single frame and rotate toward the other character. And in here, in this if statement, we were checking for if we were neutral jumping, forward jumping, backward jumping, or wall jumping. Then we were also checking to see if the combo state was not equal to wall bounce, and that we could flip. Now all of these things seem fine because the other character should not be doing any of these things. The blocking character will not be in any of these states. They will be able to flip because they can now in the 2D and 2.5D fighter. So the next place we should check is what is actually telling this character to be blocking the whole time, and that is our base AI controller. The base AI controller is what's possessing that pawn in practice mode, and so we are telling the character, the possessed pawn, which is our mutant, to manually block. Now let's go back into the editor. Let's test this out. Let's go into versus mode and let's play our game. Let's set 3D mode to be true. You see the character rotates around and the character can block. Now if I am to rotate around the character rotates properly as expected. So what's different between this and practice mode? Well, the difference is the practice mode is using an AI controller. So if we go back to our rotate toward opponent 3D, we were doing get controller set control rotation with the look at rotation. The issue here is that set control rotation is not actually meant to be used with AI controllers anymore. There was a point in Unreal Engine where this would work for AI controllers, but now it's not really safe to use it. So what we should do is check if this is an AI controller. We can do this by getting the controller, casting it to the base AI controller or our AI controller type, and checking if this is valid. If it is valid, that means it casts successfully, which means it is of type base AI controller. So a base AI controller pointer controller equals cast a base AI controller get controller. And to get this type, we need to include it. So we need to go up to the top and include base AI controller.h. Then once we have this file included, we will have access to this type. And at this point, if it is an AI controller, we don't want to do this behavior. So let's make an else statement and let's copy our get controller set control rotation, look at rotation in here. Now technically the method we're going to use here would work for both the player controllers and the AI controllers, but I am going to separate them just so you can see why this is needed. If you want, you could replace get controller set control rotation with this new line that we're going to write in here. So I'll call the variable AI controller, but it doesn't really matter. We're just checking to see if this controller is an AI controller. Then we're going to call setActorRotation if it is, and we're going to pass in getActorRotation.pitch, getActorRotation.yaw, and getActorRotation.roll. And all of this needs to be in an F rotator because set actor rotation takes in an F rotator. And an F rotator is comprised of a pitch, yaw, and roll. You can see it by hovering over the F rotator definition here. So we have pitch, yaw, and roll. Now right now this is going to get the current rotation of the actor for all these and set these, but what we want to use is the yaw of the look at rotation. We know this is the yaw because we're using the yaw here where we do b use controller rotation yaw equals true. Speaking of, we can just put that in the else statement because the AI controller doesn't need that to be done either, so that will consolidate that logic. But let's change the getActorRotation.yaw to lookAtRotation.yaw and test out our logic. You should notice that the rotation is working in practice mode with the AI controller, which is excellent. And it also works against regular characters, controllable characters, using our player controller, like in versus mode. Now, the last thing that I want to focus on, if we go into practice mode again, is what I mentioned to you earlier with the jumping. So when we jump over our character in our 2 and 2.5D fighter, everything looks good. We jump over them, the character rotates, then we jump over them again, so on and so forth. When we enter 3D mode, we can do this as well, but we can only do it once with the proper controls. Then when we try and do it again, we jump back the incorrect direction, unless we jump straight vertical or press the opposite input, my left, and jump, which is a forward jump in this case. And again, the reason for that is because if we go to our jump function in our character, it is set up to perform different types of jumps based on the direction the character is facing. And so in this first section within our jump function here, we have character state equals moving forward and not is facing right. Or character state is equal to moving backward and is facing right. And this creates a backward jump, which then applies the backward jump movement, static distance jump. However, the custom launch character is always performing a left jump when we do this, which seems to be accurate, right? Because in that case, whenever I was pressing to the right and jumping, I was jumping to the right. When I rotate around, because I jumped over my character and I'm holding right and I press jump, I'm jumping backward. But when you really think about it, I'm jumping the same direction as I was initially. If we open up Paint, very simple example here. Character 1 is this X, character 2 is this X, then left to right is this way, represented by this arrow. When we jump over this character, using that same arrow, right, that left to right motion, then we get this new image here. We'll say this is player 2 and this is player 1. They jumped over them. Character 1 jumped over character 2, and now this is character 2 right here, and this is character 1. Character 1 rotates to face character 2 here, but the world still has the same direction. This is still to the right. So 1, 2, then this is 2, 1. Direction we're applying the jump movement is still the same direction, even though the character rotated in this case. And that's why this is an issue. Now, in our specific case, it was actually a forward jump, not a backward jump that we were doing, but the exact same idea applies. So we were always doing that right jump at that point. In this case, we need to make sure that we're doing the jump based off of the direction the character is facing. Our input icons can actually stay the same, so all this logic right here is fine, but our states and our launch aren't properly being set when we're in our 3D fighter. So let's go ahead and fix this. Let's fix it for both the backward jump and the forward jump. The neutral jump is perfectly fine. It's not factoring in a direction, it's just a vertical jump. You're just jumping in the air. So we don't need to alter this one. Just the if and the else statement here. So basically what we need to do is determine if we're in a 3D fighter or a 2 or 2.5D fighter like usual for these situations. So I'm going to go above my custom launch character for my backward jump, and if get game instance, and then cast this game instance to our type, which is base game instance, then set that equal to a variable. If this succeeds, this means we were able to get our game instance, which is what we need to determine if it is a 2 or 2.5D fighter or a 3D fighter. Inside of this if statement, we can have another if statement if base game instance is fighter mode 3D. Now, if it is 3D, this means it's a 3D fighter, so we want to do our logic in here for launching the character in a 3D fighter sense. Otherwise, we want to use our standard 2 and 2.5D fighter launch. Now in here, it's basically going to be the same thing. It's going to be a custom launch character, but we're going to be changing the forces that we give it. And I'll change the comment to match this. And I'll update the 2 and 2.5D fighter comment as well, just so it's a little bit more accurate. Now we can come in here and add an else statement. This is for our 2 and 2.5D fighter, and we can copy our old custom launch character logic in here. Additionally, if you want, you can add an else statement to if the base game instance is invalid. Do a default launch character here, but if our base game instance is invalid, we have some bigger problems, and so we can just skip this if we want and remove this else statement. So I think this is looking pretty good. And then we can basically copy this over to our forward jump behavior as well in the else if statement right below. So I'll do that now. I'll copy this entire if statement from the base game instance and paste it here. Just make sure you change the jump distance to be positive right here, and change the comment to say right jump. Now we can go back up to the backward jump and convert the logic for the 3D fighter. So instead of using negative jump distance by default, what we want to do is use the jump distance multiplied by the actor's forward vector multiplied by -1. And the reason we're doing this is because we get the actor's forward vector specifically on the y-axis, because that's where we're applying the force and that's where we want to be figuring out where the character is looking. Then we have the direction that they're looking. If we multiply it by -1, we turn it around, which is behind us, or behind the character's forward vector, or backward vector, if you will. And then you multiply that by your jump distance to get the actual jump force. For the forward jump, we do the same thing, but we don't need to multiply by -1. So you could multiply by get actor forward vector times 1.0, but then you're just doing a lot of extra stuff you don't really need to be doing. Anything multiplied by 1 is itself. So we don't need to do that, and that means we don't need to put it in parentheses either. We can just do jump distance times get actor forward vector dot y. And you can launch the game again and test it out. And you should see that it is working. I can jump for my 2 and 2.5D fighter regularly, both back and forth, and I can do it for my 3D fighter as well. This will work for player 1 and player 2. There will be some oddities when you're jumping forward in a given direction. So when we flip sides and we try and jump forward, we are going to start jumping forward, then you're going to see we're going to get pushed backward. This is actually due to something in our animation blueprint. We had a forward jump forces that we were applying during the animation to make it look nicer and feel better while playing the game. And this does not account for our new logic. However, I'm not going to clean this up in today's episode because this is something that's going to be cleaned up in the fighting game in general. We don't need to do it this way anymore. And even if we want to do it this way, we have a cleaner way to do it now with our custom launch character. So if you go to your forward jump animation, you find your anim notify on there, you search your event graph for that anim notify, and you see your forces like I have here, you'll see the issue. But again, we're not going to address that here. We'll address that in a later episode in the fighter, and this will resolve itself. Thank you guys so much for watching. I hope you enjoyed this episode on cleaning up our 3D fighter and improving it. We got our hurt boxes working for our 3D fighter. If you enjoyed this episode and it helped you with your 3D fighter, then please subscribe and consider joining the Patreon, YouTube membership, and Discord subscriptions to help benefit the channel. If you ran into any problems while following this tutorial or any of my tutorials, feel free to join the Discord community. There's a link in the description, and I would be happy to help you out. Thank you so much for watching. I'm Shawnthebro, and I'll see you in the next one. Goodbye, guys.